Hi, everyone. My name is Riley Frost, and I am an undergraduate student at the University of New England studying biochemistry. Just recently, I was given the honor of hosting Dr. Matthew Charette in his seminar about the transpolar drift as source of riverine and shelf-derived trace elements to the Central Arctic Ocean. In relation to that today, I'm going to be presenting research done by Dr. Thomas Crumpin and his colleagues on the effect of climate change on the transpolar drift and marine ecosystems. So let's get right into it. As a brief overview, I'm going to be explaining climate change and how it affects Arctic climates. I'm going to be relating the effects of climate change to the ability of the transpolar drift to quote unquote do its job. I'm going to be discussing the results of the research done by Dr. Crumpin and his colleagues, and I'm also going to clarify this research and give future insight as to what this research may hold. So to begin, let's talk about climate change, and in this case, specifically global warming. Global warming is caused by the release of gases such as those from your car and power plants and other machinery that are trapped in Earth's atmosphere. And when these gases are trapped in Earth's atmosphere, it is very hard for heat to leave Earth. And because of this, these gases are trapping heat within Earth's atmosphere, causing the Earth temperature to rise. And you can imagine that as the Earth's temperature rises, it's going to be harder and harder for these Arctic, icy, cold ecosystems to stay frozen. And it is estimated that in 1 to 2 centuries, the average Arctic temperature will rise roughly 5 degrees Celsius from where it is now. And this increase in temperature is only going to escalate the rate that the Arctic is melting and the Arctic ice is melting. And without ice, the transpolar drift cannot play its role in supporting marine ecosystems. Now, I bet a lot of you are wondering what the transpolar drift is. And in this picture off to the left, this map, this is Siberia and northern Russia, Alaska, Canada, as you can see. And in the Arctic Ocean right here, there is a couple of currents, one being the Beaufort Gyre, which is a circular current right in the Canadian Gulf and the Beaufort Sea. And then you have the transpolar drift stream, and this leads to the Fram Strait. So the transpolar drift is basically a current that runs from northern Russia, the Leptev Sea and the Chukchi Sea, as you see here, down towards Greenland and into the Atlantic Ocean. And so all these rivers, that run off into the ocean from Russia, they bring sediments and other materials and even pollutants into the Arctic. And what the transpolar drift does is all of the things that come into the Arctic Ocean freeze because it's very cold, and they freeze into ice. And the transpolar drift brings these pieces of ice towards the Arctic Ocean, and they begin to melt and melt and melt and melt until they become just water and enter the Arctic Ocean. And so it's basically responsible for redistributing sediments, particles, pollutants, and more away from the Arctic Ocean. Of course, there's always going to be some in the Arctic Ocean, but you don't want all of these materials inside of the Arctic Ocean. With all of these materials inside of the Arctic Ocean, that can have detrimental effects on the ecosystems there, the environment, the wildlife. But at the same time, if too much of these materials is built up in the Arctic Ocean, then that means that some of these places that the transpolar drift brings these sediments and materials lack them. And so the high amount in the Arctic Ocean leads to a lack in other places, which is bad for these environments because they rely on these things that they get from the transpolar drift. And so research done by Dr. Thomas Crumpin and his colleagues outlines this whole matter to assess, the current situation of the transpolar drift and what the future holds. So in his publication, the Arctic warming interrupts the transpolar drift and affects long-range transport of sea ice and ice-rafted matter. They use satellite data and known geographical data to track things such as the rate of formation and melting of specific packs of ice, trajectories in which the ice traveled, and the thickness, concentration, depth of the ice, and even the uptake of sediment by the ice. And this research was done over the course of roughly 25 years from the early 90s to around 2017. So from these things that they measured, Dr. Crumpin and his colleagues found that ice formed in deeper waters contain less material for the transpolar drift to carry. And this makes sense because near the coast, you have all these sediments coming in and all these pollutants and other materials. And there near the coast, they're in a high concentration. It takes longer for them to drift out into the ocean. So ice that forms deeper out in the ocean doesn't have as much of those materials compared to ice that forms right where those materials are coming from. And so therefore, the ice that the transpolar drift is bringing to the Fram Strait and further isn't as rich in these materials. They also found that less ice peaks reach the outer limits of the Arctic Ocean than in the past. And you can see this in the graph off to the left here. That's labeled annually average survival rate of Siberian shelf ice. Siberian shelf ice is just ice on the shelf of Siberia. It's just ice on the coast of Siberia. And as you can see, from 1995 to 2015, the lifespan has just decreased. The ice is not lasting as long as it did in 1995 anymore. And so because of that, the ice that the transpolar drift is carrying is melting before it gets outside of the Arctic Ocean. And so these materials are just being basically just kept in the Arctic Ocean. And so other environments, marine environments, are being deprived of these nutrients, microbiota, and even pollutants that are now building up in the Arctic Ocean. And these buildups are also bad for the Arctic Ocean because too much of these pollutants or even too much of these sediments can throw off a whole ecosystem. And so they also found that the probability of newly formed ice reaching the outer limits of the Arctic Ocean has decreased, as the graph shows. And in most recent years, material carried in ice has been deposited back into the Arctic Ocean, like I said. So the impact that this has on marine ecosystems is that when you have a buildup of things that other places need in one area, those other places are going to be hurt because the organisms in those places need those nutrients and sediments and materials to survive. However, at the same time, it's not only good things that ecosystem needs. It's things like pollutants and microplastics and things of that nature that also can't build up in the Arctic Ocean because that will destroy the Arctic Ocean environments for marine life. These things need to be evenly dispersed, or else one area is going to be completely destroyed. And so this is basically what Dr. Thomas Crumpin outlined in his research, and him and his colleagues found that because of global warming, these ice caps that the transpolar drift is responsible for bringing out of the Arctic Ocean is not doing so as effectively as it used to. And because of that, the Arctic Ocean environment could be destroyed. And so in conclusion, because of climate change, ice isn't forming and freezing important materials that need to be evenly dispersed between many marine environments. The transpolar drift that's responsible for carrying that ice and these materials can't work effectively if it's too warm for ice to form or for ice to completely reach the edge of the Arctic Ocean. And so therefore, climate change is creating an excess amount of pollutants, sediments, and other materials in the Arctic Ocean, which creates a lack of these materials in other places, such as the Atlantic Ocean. And so because of this, it's predicted that this buildup in the Arctic Ocean is going to have a negative impact on marine life, and the deprivation of these materials for other marine life is also going to have a negative impact. And here are my sources, and I'd like to say thank you all for listening, and I hope that you enjoyed the video, and if you have any questions, feel free to reach out. Thank you.